Part 3, Partial Fraction Decomposition, Unique Irreducible Quadratic Factors. Sometimes when we are looking at a fraction we want to decompose, so we want to do this partial fraction decomposition, we will have factors in the denominator that are quadratic but cannot be factored any further. And when this happens, in the partial fraction decomposition, the numerators will have something like an ax plus b. For example, if I have this rational expression right here, notice that the two factors in the denominator are quadratic but cannot be factored any further. So in this case, I'm going to have ax plus b over this first factor and cx plus d over the second factor. And then I'll need to find the a and the b and the c and d like we did before, but I will have some x's in the numerators also when I have factors in the denominator that are quadratic but cannot be factored further. For this particular one, if we were to solve it, we would get a is 3, b is 1, c is 0, and d is 2. And so we get 3x plus 1 over x squared plus 1 plus 2 over x squared plus 2x plus 4. Let's try an example. We'll do the partial fraction decomposition for this expression. So I have 3x squared minus 2x plus 4 over x minus 2 times x squared plus 2x plus 4. So this denominator has already been factored for us. Notice that the x minus 2 is a linear factor, so I can just do a over x minus 2. But x squared plus 2x plus 4 is a quadratic factor, so I'll have a bx plus c over x squared plus 2x plus 4. So that is the setup for this. Now I need to find a, b, and c. And I'll start the same way we did with the linear factors. I'll clear the fractions, so I'm multiplying both sides by that common denominator. So it cancels on the left side. I have 3x squared minus 2x plus 4. On the right side, I have a times x squared plus 2x plus 4 plus bx plus c times x minus 2. Now, the only way I can make either of these factors equal to 0, if I set x equal 2, then x minus 2 equals 0. So I'll start with that. X equals 2. On the left side, I have 3 times 2 squared minus 2 times 2 plus 4. On the right side, I have a times 2 squared plus 2 times 2 plus 4 plus bx plus c times 0. So this part's gone. Then I'm going to simplify everything. On the left side, I have 12 minus 4 plus 4. On the right side, I have a times 4 plus 4 plus 4. So 12 equals 12a, and a equals 1. All right, so I found the a equals 1. So I have 1 over x minus 2. I don't know what b and c are yet, so I have something over x squared plus 2x plus 4. To find b and c, there's no other way I can make any other factor equal to 0 by letting x be a number. So instead, what I'm going to do is I'm going to take a equals 1 and substitute it into this equation right here, and then I'll distribute through and equate like terms. So I'm going to make a equal 1 and distribute through on the right side. So the left side is still 3x squared minus 2x plus 4. On the right side, I'm going to distribute a through the first parentheses. A is 1, so I'm distributing 1 of x squared plus 2x plus 4. And then I'm going to distribute with the bx plus c times x plus 2. So first, bx times x is bx squared. Outside, negative 2bx. Inside is cx. And last is negative 2c. Next, I'm going to collect my like terms on the right side. So I'm going to collect the x squareds. I have x squared plus bx squared. And then the x terms, I have a 2x minus 2bx plus cx. And the constants, I have a 4 minus 2c. I can factor out the x squared terms. I can factor out the x squared, and I have 1 plus b. Factor out the x for the x terms. I have 2 minus 2b plus c. And then my constant, I have 4 minus 2c. Now I can equate the like terms. On the left side, I have 3x squared. On the right side, I have 1 plus b x squared. So 3 equals 1 plus b. Then on the left side, I have negative 2x. And on the right side, with the x, I have 2 minus 2b plus c. Then on the left side, my constant is 4. On the right side, the constant is 4 minus 2c. So I've equated the like terms. And then I have this system of equation with these three equations. This one's not too difficult to solve. The first equation, 3 equals 1 plus b, means that b equals 2. And the last equation, if I subtract 4, I get 0 equals negative 2c. Divide by negative 2, and I get c equals 0. So I have bx plus c, which is 2x plus 0. And here's my partial fraction decomposition. I don't have to write that plus 0 at the end, obviously, but you can if you want to.